Hi everyone, I'm Peter and I'm crazy about Pandigital numbers. What are they, you may ask? As a good question, I'll explain. In base 10, they're just simply numbers that contain all the digits 0 through to 9 arranged in any order, and multi-digital if they contain the same digits but repeated more than once but an equal number of times. And similar rules apply to numbers in other bases, not just base 10. And that's it. They're otherwise just ordinary numbers and behave the same way that any other number would when you add, subtract or multiply it. They are simply recreational. The interest lies purely in the pattern of the digits and nothing more. To me, they are a form of mathematical art. They are simply to be admired. And the best thing is you don't need a degree in maths to appreciate them. I have searched for these patterns for many years, and I'd like to share with you some of my favourite examples. These two pandigital numbers, when added together, equals another pandigital number. And when multiplied, you get the square of another pandigital number. This is quite interesting because there's not many like this. However, it gets even better because if you write the square out in full, you get a number that is doubly pandigital. These patterns arising through adding and multiplying like this is unique. These two zeroless numbers are also unique and simply amaze me. Their product is a square of this zeroless number, and when you reverse their digits and multiply them together, you get the square of another zeroless number. But take a closer look. This new square is a reverse of the digits in the original square. This is a simply amazing coincidence, literally one of a kind. And perhaps Pythagoras himself would be pleased with this right-angled triangle. It's one of several that has pandigital sides, but this is the only one that is completely zeroless. And how about this circle? The sum of any two adjacent cubes equals the adjoining pandigital number in the circumference. There's also a smaller zeroless circle like this, but I'll leave that as a challenge for you to find. Taking things to the third dimension, these four cubes all have pandigital sides, and the total volume of the first three equals the volume of the fourth. This example has a bonus that adding the sides together of the three smallest cubes is also pandigital. The examples I've just shown are literally just the tip of the iceberg. There's an endless number of other patterns just waiting to be discovered. Back in 1980, I was inspired by an article written by Martin Gardner for Scientific American, and I spent many hours using nothing more than a simple pocket calculator to find the patterns. Nowadays, there's a lot more about pandigital numbers on the internet, but I will say you'll get a lot more satisfaction by finding the patterns yourself. Hopefully, this short video will inspire you to look for your own patterns, and if you do find something, I'd love to hear from you. So let me know in the comments below. All the very best. And a big thanks to my subscribers. Hope to see you next time.